Okay, I sent you the syllabus. You must receive it shortly, but I have it also in here. So important things about the course is the book in here in the page 1, which is the Introductory to Circuit Analysis 13 edition by Lested. So you can find the PDF also online, or you can order the book. Either way is fine with me, but usually you have to have the book because the homework will be from the problem at the end of the book. So you need to have access to the book. As you know, also for the class, Mondays we have the lecture, and on Wednesday we have the lab section. For the class part, I think also here in the first part also we will go into it in more detail. As you know, the course is for the electrical circuit analysis, where we are going to learn about Ohm law, Kirchhoff's voltage and current law, and also the way how to analyze and solve the circuit problems using some of the technique like superposition, mesh analysis, nodal analysis, or Newton and Thevenin equivalent circuit. Then we are going to learn also how to analyze the steady state circuit when we have combination of resistor and capacitor and combination of resistor and inductor. And this is for the lecture part. For the circuit part also, we are going to, whatever we learn in the theory, we are going to do some experiment to get more understanding of what we learned from the theory. So usually in the experiment part, we have some experiment that you need to run, and then you have to write a report for it, and your activity in the class, and at the end your lab report will be you will get some, receive some credit, which will be part of your final credit and the score for this course. These are like the 10 experiments that we are going to do, like a color code for the resistor, how to read resistor when they have color code, experiment regarding testing the Ohm law, doing some experiment to get familiar more with series circuit, with parallel circuit, with the combination of series and parallel circuit. We also going to learn about troubleshooting, and we also going to test some of the theory like superposition or Thevenin Norton theory that we learned. Step by step, we are going to learn about these things. So don't need to be worried. Another important part in the syllabus is this part, which is the grading policy. So usually homework, quizzes, and class participation considered as a 20% of your final grade. Midterm exam considered as a 35%. Lab exam and the report considered as a 20%. And final exam is 25%. So these are kind of part that you will get credit for in this course, and these are the letter grading and the numerical grade range that you will get. So whatever you have in here, at the end, the combination will be up to 100, and depends what number you get from the 100. This will be the lesser grades of A minus, B, and C that you may get. Any questions so far? If you have any question, please raise hand. If not, I can continue. Okay. So here also mention the objective of the course, as I mentioned, but in order to cover this one and also the homework section, let's go to the next page, which is a table. It's very important, this part of syllabus and this table, because you know each week what topic is going to be covered. At the end of each week, what will be the homework that you are supposed to do. So, for example, for the week 1, we are going to go over the introduction of the introduction chapter, which is chapter 1, and you have to do this homework for the next week. Usually, when a week is finished, you have to do this chapter questions that we have in here. So you have to have the book, going to the question at the end of the book and answer this question. When it's a week 2 and 3, so it's a topic that is covered in 2 weeks. So here, if I finish chapter 2, I will let you know that chapter 2 is finished. So for chapter 2, these are the questions. If chapter 2 and 3 is finished, I will let you, okay, for the next week, you have to do the chapter 2 and 3. So usually whenever a chapter is finished, you have to submit the question for that chapter next week, okay? Any question? So it's repeat for the entire semester. So I'm not gonna give you on a weekly basis the homework. You have this table. Whenever the week is finished, you know which chapter is covered and what problem you need to solve. Any question? Yes, Paulina?
Will we be handing in Blackboard or emailing it to you?
Okay, so in Blackboard, I will create an assignment for you that is homework 1. So you will submit your homework to that assignment.
Okay, great. Thanks.
Okay. So usually it's like you upload into the Blackboard. Through the Blackboard, I can grade, give you the feedback, and submit your grade over there. Okay, any question? So as I said, I think the PDF of the book is available, but I'm not sure if the PDF of the 13th edition is also available. I know that 11th edition is available, but I think if you look for it, you can find the 13th edition as well. Okay, so if there is no other question, let's start chapter 1, which is the kind of introduction. The topics in the chapter 1, you usually know about it. It's just, let me bring the chapter 1 and go over it. So we're just going to go over some topics like what's happened in the past, how this electrical circuits is evolved during like a little bit of history. And after that, a little bit review on some of the numerical work that we do with the numbers, like power of 10, engineering notations, scientific notations, just in order to know when you see different number, how just it's like a review, more of like a review. I know all of you know the topic, just is like a review to bring these things to your mind. So as I said, we are going to learn a little, become familiar with SI system of the units, understanding the importance of the power of 10 and how to work with them in numerical calculation, and how to convert any quantity in different units and another system with the confidence. So when we say different unit and different system, we mean like the SI system or the imperial system. So if you know, like sometimes when we are measuring a distance, we can say the unit in meter, or we can say the unit in inch, millimeter, or feet. So these are like different units that you can work with it. And then you important things in here is for you to know how to convert number from each unit to another unit. It just, you can have a table for the conversion, and whenever you need it, you just do the conversion. So just a little background on this electrical and electronic industry. If we look at the era from like before 1900, that is like a century ago, then if we go forward little by little, these are like the development and achievement we have. Like we have vacuum tube amplifier, FM radio is discovered around 1929. Then we have black and white TVs. Then we have color TVs. Around 950, we have electronic computer, solid states switches, mobile telephone. Around 1958, we had ICs development, floppy disk. Around 1977, first assembled PC is discovered. 1979, like 2 years after that, we had first laptop computer. In 1983, almost 4 years after what we talk, we had Apple's mouse. Then we had cell phones. GPS is developed near 2000. We had Wi-Fi discovered that kind of changed everything. We had around 2000 Pentium 4 chips with 1.5 gigahertz for the computer. Then, as you will see, everything doing fast. We had nanotechnology, MEMS resistor, iPhones, Intel Core processor, and lots of things that you can name it better than me. So as you see, in the past, there wasn't that much development, but after around 2000 and after that, everything is going fast and forward. So these days, everything is working, like anything that you touch in your work, in your home, has like a kind of electrical circuit or electronic circuit. So it's very important for you to know the basics of the circuit analysis. So if you want to work with it, if you want to like repair it, if you want to kind of develop it, if you know the kind of circuit analysis, is just like a basic. And then the other topic that we are going to talk about is the unit of measurement. As I said, we've done lots of measurement, and we have different type of the unit. We are going to learn how to do the conversion and how to use this unit. So for some of the quantity, we have some specific unit. Like we usually know that for the distance, we use meter or feet. For the time, we use minutes, we use hour, we use second. But anything that can be achieved from any mass between these two, for example, velocity or speed, it's the distance divided by time. So the unit for the velocity can come from the unit of the distance divided by the unit of time. So the unit of distance, if it's defined by foot, and the unit of time, if it's defined by minute, the unit that you have for the velocity is foot per minute. But usually, if you remember from the car, or if you see in the road, usually the speed limit or the speed is usually mentioned by mile per hour, but here the number that you have is a foot per minute. So we have some of the unit which are kind of as a standard or more popular than the other, and it's good to know how to convert any number from any other unit to the standard one. So we are going to learn how to do this conversion. Also here, as I said, again, here is also mentioned that the unit mostly were either the English unit or the imperial one or the metric unit. So the English system is based on the single standards. The metric is subdivided also to interrelated standards, which is MKS, meter, kilograms, and second, or CGS, which is centimeter, grams, and second, which is centimeter, or the grams is the smaller case for the meter and the kilogram. But here it's a very important table that we have different units for the English system, for the metric, and the SI system. The SI system usually follow the metric system, but here is what we have and the relationship between each of them. For example, for lengths, if you want to measure any distance or any length, in the English system, you have yard, which is almost 0.914 meter. In the metric system, in the MKS one, we have meter for measurement. We also have inch, and we also have centimeter. 1 meter is equal to 39.37 inch. 1 meter is also equivalent to 100 centimeter. In the other system, that is centimeter is the base for the unit. We have the relationship between the centimeter and inch, that usually 2.54 centimeter is considered as 1 inch. And in the SI system, if we measure any distance, we just use the unit for the unit of meter for it. No matter how small or how big is the number, we just use this one. If we have mass, in the English system, we use a sludge, which is 14.6 kilograms. In the metric system, either we use kilograms or we use gram. In the SI system, which is the standard system of the unit, we use kilograms. So in the standard system, if you are going to talk about mass of any object, you use kilograms. For the English system, we have pound, which is 4.45 Newton. In the metric system, we use Newton, and for the smaller one, we use dyne. But in the SI system, we use Newton. For the temperature, in English system, we use Fahrenheit, which is this one is relationship between 1 Fahrenheit and Celsius. And for the metric system, we have Celsius or centigrade, and this is the relationship how to convert from Celsius Fahrenheit to Celsius. And in this SI system, we use Kelvin, and this is the relationship for between the Kelvin temperature and the centigrade temperature. For the energy, in the English system, we use foot-pound, or which is equal to 1.356 joules. In metric system, we use Newton meter or joules, which is equal to 0.7376 foot-pound. Again, we have another unit for metric, and for the SI system, which is the standard unit, we just use joules. For the time, in English system, we use second. In metric system, we use second. In the SI system, we also use second. So the only things that has the same unit in the different system is time, which is in all of them is second. Any questions so far? Okay, so how you are going to use this table? The point is that you will get one measurement in any of these units. For example, I will say I have 2 yards of wire, convert it to SI system. So you have to know what is the relationship between yard and meter, and then converts the number that you have, or any of these things similarly. So you just need to note this table, relationship between the unit from this table, and then do the conversion. And then here it has a kind of illustration of different unit in order to have kind of comparison of one standard unit in each of these systems, kind of how big or how small it is. So this is 1 meter, this is 1 yard, and this is 1 feet. So usually we said that the English system 1 yard is 0.9. So as you see, it's slightly smaller than 1 meter. 1 feet is around 32 centimeter. So as you see, is 1/3 of a meter. Here is the inch and 1 centimeter. As we said, 1 inch is 2.5 centimeter. So that's why it's kind of 2.5 in a size, as you will see in here. Same things for the mass, like one sludge, 1 kilograms and 1 gram, how big or how small they are. Same things for the force, same things for the temperature. For example, in temperature, 0 degrees Celsius in Kelvin is 273, while in Fahrenheit is 32. And then this one for energy. So this slide also is very important in order to know all this information that I'm presenting also, by the way, is available in the book. So you don't need to worry about like taking notes because everything is available in the book. But feel free if you wanna write any notes, and if you need me to repeat anything or you like need more explanation, just let me know. Any question? So the other topic that we are going to talk is that usually we have numbers in the various form with little concern for the format we use, how many digits we use for the measurements, or like, in other words, if we want to say, as it mentioned in here, the numbers that we are dealing with, either they are exact number, nothing after point, or they are approximate. There are some numbers after the point and we are not sure about the exact value. And then we are going to also learn how to do the multiplication. Then textbook title and the author is mentioned in the first page of the syllabus. If you want to refer to, I emailed you the syllabus at the beginning of the class. So let's do an example together to see what is this exact number and how we're dealing with different type of number. So it's an example in here. It said, perform the indicated operation with the following approximate number and round off to the appropriate level of accuracy. So here I have this number with one number after the point, 2 numeric after the point, and 3 numeric after the point. If I add all these things together, it will be the number. But if I want to do the approximate, I will do it usually with one number after the point, and this number is close to 7. So usually is that you will round this one, then round this one, and then this one. So if I want to round 6, is above 5. So any number above 5 will be round to the next one. So this 56 becomes 6 or 60, in other words. This 60, then it's become 66. If I want to, again, make this number in here, let me also bring the pointer so you could see. If I want to also round up this 6 in here, it will go to become this one 7 and this one 0. So this number will be determined by this one. If I want to do the math for here, if you do the normal math, this will be the output. But if I want to round it only by 2 number after the point, so this 4, it's smaller than 5. So it will be round down, it becomes 0. Then the remaining number is 4, 9. 9 is above 5. When you round, if usually for the rounding also, if the number is above 5, you round it to 10. If the number is below 5, you round it to 0. So if I round 9 to 10, this 4 become 5, this 9 becomes 0, and this is the final answer. So here it's mentioned that round off the following number to the hundredths of the place. So these are like a math from, I don't know, elementary, primary. We know it, but just review it. So this number of 9 is above 5. We round it to the next number. It becomes 0. This one becomes 2. And then because 2 is the hundredths of the place, 2 number after the point, we just stop. We don't do any more round off. This one is like a lot of number after the point, so we have to do some round off. I will going to round off 8 first. It's above 5, so I will round it to the next number. These 2 become 3. This one becomes 0. Then I have this 3 in here. I have to round off one more time. Because 3 is below 0, it will be round off to 0. But still, I have remaining number is 0.053. It's 3 number after the point, and I need 2. So I also have to round off this 3. 3 is below 5, so I will round it to 0, and then the remaining will be 0.5. So step by step, from right to left, you will round off the numbers until you reach the level of accuracy that you want. And these are some examples that, for example, if I have this number and I want to do it with the tenths of the place, one level of accuracy will be this one. Hundredths place of accuracy, I need 2 number, so this 7 will be round up to 8. And then if I want thousands place of accuracy, I will start from right. This 4 becomes 0. This 3 number will remain, and it will be very good. Any question? Okay, the other topic that we are going to discuss is the power of 10. And for the power of 10, usually when we have big number or very small number, instead of writing down like a big numbers to do the calculation or very small number, we usually convert them to the power of 10, either power of, if it's like a big number, 10 power of positive. If it's a small number, less than 1, it will be 10 power of negative. So as you will see in here, number 1 can be shown by 10 power of 0 because any number power of 0 will be equal to 1. 10 by itself is 10 power of 1. 100 is 10 power of 2. 1000 is 10 power of 3, and so on. In like the easy form is that for any 0 that you will see in front of a number, you will add it to the power of 10. Similarly, 0.1 can be shown as a 10 power of minus 1. 1 over 100 or 0.01 is shown by 10 power of negative 2, 10 power of negative 3, and 10 power of negative 4. Any question up to here? In my mind, I assume everybody like know power of 10, but in case anybody forgot or need more explanation, please raise hand and let me know. Any question? Okay, so when we know how to write down the power of 10, another thing is to how to do the math operation with them. So here is that when we have power of 10 multiplying together. If I have any number like 10 power of n multiplied by another number which is 10 power of m, the result of this math will be 110 as a base, and for the power I will just add this number. For example, if I have 10 power of 3 multiplied by 10 power of 4, I will just write down 110, will add up the power. So it will be 10 power of 7. Another example here is 10 power of minus 5. This one is 10 power of 2. If I want to do the math, I will write down one base and will add the power together. Negative 5 plus 2. The result is negative 3. Same things for the other operation. If I have any number, assume 10 power of n, divided by another number, 10 power of m. So the result will be 10 power of n minus m. So here is an example. If I have 10 power of 5 divided by 10 power of 2, I will just write down one of the base, and for the power, the top one minus the bottom one. So 5 minus 2 will be 3. Another example in here, it's 10 power of 3 divided by 10 power of negative 4. It will be one of the base, the top 3 minus negative 4. Minus by minus become positive, and the result is 10 power of 7. If I have a number in power of 10, and I'm going to again to do it to reach it to the power of m, the result is that you will write down one of the 10 as a base, and then multiply the power, n multiplied by m. Here is an example. If I have 10 power of 2 to power of 4, I will just write down 10 and multiply these two numbers. 2 multiplied by 4 equal to 8. Another example is this one. This one is 10 power of 3 to the power of negative 2. So I will write down 10 and multiply these two together. 3 multiplied by negative 2 become 10 negative 6. Here is another example. 0.01 to the power of negative 3. This number is 10 power of negative 2 to the power of negative 3. So I will write down one of the power, one of the 10, and then multiply these two together. Negative 2 multiplied by negative 3 is 6. I don't know why I lost it. Okay. Any questions so far? Okay, I kind of lost where I was in here. Oh. We mentioned this one, and also I will go with, oops, sorry. 18, 19. Okay, so we just learned about the addition, subtraction, multiplication, and the division of the power of 10. And now we are going to learn if we have, like, whatever we just followed, it was just only 10 power of something. But now we are going to see if we have like some big numbers, like 1600 or 75,000, how we are going to add this number using power of 10. So is that first you have to convert your number to some a multiplied by 10 power of something. For example, in here, 6300 will be 6.3. We usually convert it to like one number, point something, if you want to convert it. So it has one exact number. We don't say it's 63 multiplied by 100. We say this one is in a way that you have just one exact number. So this one become 6.3 multiplied by 1000. 75 is, we can say 7.5 multiplied by 10,000, but here it just consider it as 1,000. It's better to have the power of 10 for both numbers the same. So if this one is 10 power of 3, it's better to have this one also in 10 power of 3. And then here is the result. You just add up the number and then write down one of these 10 power of n. So here I will add 6.3 multiplied by 75 multiplied by one of these 10. And then the result is 81.3 multiplied by 10 power of 3. So if you do the math in here, add 6,300 to 75,000, the result is 81,300. If you convert it to the 10 power of 3, it will be this number. So here is another example as well. This number, I have this one, and also I have this number. So if you look at the number of zeros that you have in here 1, 2, 3, 4, 5. So this one is just 96 power of negative 10. But this one, if you look 1, 2, 3, 4, 5, 6, I have 6 number after point. So it will be 10 power of negative 6. But in this case, I will consider the same one, which is 10 power of negative 5. So this one become 96. And this one become 8.6. And then I will just add up the number, 96 minus 8.6. And here, 10 power of 5, just write one of them and multiply. It's like you get the factorization of this one. You factorize this one from both terms. From this one, if you factor, it will be 96. If you factor from this one, it will be 8.6. And then do the math for this part and then multiply by 10 power of 5. It kind of sometimes make it easier in order to do the math, but usually is that because it's kind of become like a notations or the standard way how to deal with the big number or a small number, and you will see in most of the like scientific book, this is the approach that they use. It's good to know and have some sort of practice to understanding it better. Otherwise, you can add this number and this number to the calculator and it will give you the final answer. But the point is that sometimes calculator also use this format, and the result that you will get is the format of 10 power of something. So it's good to know how to deal with number when they and convert them to the power of 10. This is another example. If you have a big number like this, a small number or maybe big number, depends, you can consider both. In power of 10 power of m, another number in 10 power of m, so different number of power, but they are doing the multiplication. In this case, you just multiply the number by itself. And then for the power of 10, as we said, if we have 10 power of m multiplied by 10 power of m, you just write down one of the 10 as a base and we'll add up the number of power. So it will be like this. Here is an example. This number is equal to 2 multiplied by 10 power of negative 4. This number is 7 multiplied by 10 power of negative 6. If I want to do the math, first I will multiply a and b together. So 2 multiplied by 7. And then I will do the math for this part. 2 multiplied by 7 is 14. when I have 10 power of negative 4 multiplied by 10 power of negative 6, I will just write down one of the power and add up as a base and add up the power. Negative 4, negative 6, the result is negative 10. And then for part B, I have this number and this one. I'm going to multiply them. First, convert them to the power of 10. This one is 3.4 multiplied by 10 power of 5. This one is 61 multiplied by 10 power of negative 5. If I want to do the math, I will multiply the number as it's mentioned in here. And then for the power of 10, I will write down one of the power and add up the one of the 10 and add up the power. That in this case, 5 plus negative 5 is 0. 10 power of 0 is equal to 1. So this will be your result. And we have the same things for division. So if I have a number divided by another number in power of 10, I will just do the part for the numbers. And then for the power of 10, as we said, 10 power of n divided by 10 power of m, I will write one of the 10 as a base and then do the subtraction between the top one and the bottom one. So let's do these two examples together. I have 47 multiplied by 10 power of negative 5. This number is 2 multiplied by 10 negative 3. If I do the math for here, 47 divided by 2, and this part for the power of 10. 47 divided by 2 is 23.5, and this part is 10 negative 5 minus 3, which become negative 2. This is another example. This number is 69 multiplied by 10 power of 4. This one is 13 multiplied by 10 power of negative 8. And in order to do the math, I will do the division for 69 divided by 13 and 10 power of 4 divided by 10 power of negative 8. 69 divided by 13 is 5.31. This one divided by this one is 10 power of 12. So 4 minus 8 is become 12. And the last one, if I have any number in power of 10 and I'm going to bring this big number to the power of another number, you will distribute this power into the parentheses. Then first you will bring a to the power of m, and then you bring 10 power of m to the power of m, which is you just multiply the power. So this is the example. This number is 3 multiplied by 10 power of negative 5. You will bring this number to the power of 3. First, 3 to the power of 3, and then 10 power of negative 5 to the power of 3. So 3 multiplied power of 3 is 27. And this one is just multiplication between these two numbers. Negative 5 multiplied by 3 is 50. Another example in here, this very big number that you see in here is actually 9.08 multiplied by 10 power of 7. And for power of 7, you know, you will just count how many numbers in front of the 9 or where you put the point, and then this will be the power of 10, and then you are going to bring it to the power of 2. First, I will bring 9.08 to the power of 2, and then 10 power of 7 to the power of 2. And then this one become 82.45, and this one become 10 power of 14. Any question? Okay, the next, or actually the last topic is No, it's not the last topic. Is the next topic in here. Is the scientific notation and engineering notation. Let's do it with an example. So sometimes if you work with the calculator, you see that in the engineering notation, instead of 10 power of something, they use E. So instead of 10, they use just the letter E. And if you do the math in any of these, you will see, like, depends on how you put your calculator, in what system or the mode, you will see, for example, instead of 1.3, you will get 3.3 e power of -1. This E in here, capital E in here, means 10. It's like this number multiplied by 10 power of -1. And then here is that depends on what level of accuracy they put. If they use 100-point accuracy, the numbers will show with the point, two number after the point. But if it's different level, you will see you can also show this number exactly a similar number, but e power of -E3, or this one. So either it's a 10 power of -1, e power of -2, or like the normal one, or it can be the power of 3. So any number that you have, the calculator will show it to you as a 10 power. It will convert it to the 10 power of -3, and then the number in here will become big or small, depends on what is the value. Another important thing that is good to know is this table that gives you the prefix for some of the 10 power of this number. For example, if we have any number that multiply by 10 power of 3, you can take off 10 power of 3 and instead say the units in kilo, and the symbol is K. Is 10 power of 6, you use mega, you use it with capital M. 10 power of 9, you use giga, capital G. 12 tetra, 15 peta, and exa for 18. And similarly, if it's negative number, 10 power of -3, you call it milli. 10 power of -6, you call it micro. 10 power of 9, you call it nano, pico, femto, and otto. And these are the symbols that you will use in front of unit. So in order to bring this number, this 10 power of something, you just bring this symbol in front of the number and read it like this. Let's do an example to make it more clear. If we say that we have a resistor that is this number of ohms, if you convert it to 10 power, is 1 multiplied by 10 power of 6 ohm. And if we look at the table in here, 10 power of 6 is mega. So I can say this resistor is 1 mega ohm. Or in other words, if you say somewhere that mentioned there is a resistor of 1 mega ohm, it means the value of this resistor is 1 multiplied by 10 power of 6. Another example is here. If you have this number in meter, you can get this 10 power of 3 out and say it's 100 multiplied by 10 power of 3. And then you can say, if you look at this table, 10 power of 3 is kilo. So you can say this number is 100 kilometers. And in order to write it down with the unit, you just write down 100. Instead of this 10 power of 3, you just write K. M is the meter, and this one is coming for the kilo. So if you also look more deep into this table, you will see all these 10 power of numbers are the multiplication by then 3. It's like 10 power of 3, then it's 6, then 9, then 12, then 15, and 18. And here is -3, -6, -9. So when you are going to do the conversion, in order to make the number in a big format or in a smaller format, you have to make sure that you have to take out 10 power of 3 or anything that is multiplication of 10 power of 3. Any question? So here let's do an example that's going to work between the conversion of the units from one unit to another one. For example, in this example, it asks us to convert 6.8 minutes to second. So we know that 1 minute is equal to 60 seconds. So usually the method that we use for the conversion is similar to a stoichiometry method that you may be familiar with it from the physics or the chemistry. So usually we write down it in this format, like as a relation, that 60 seconds equal to 1 minute. And if you do the division in here, it will be equal to 1 because it's equality. If you divide this number by this number, the result should be 1. When we have any number, like when we look at it like this, when we have 6.8 minutes, we have to use this one in a way that the minute be in the bottom part. So this one cancel out with this one. And then if you multiply this by this, the result or the only remaining unit is second. Now, if it was different, for example, if it was 6.8 seconds, you want to convert it to the minute, then the unit in here was second. The one that is come to the bottom part in here, you have to make sure this one and this one have the same unit in order to cancel them out. So in the first step, when you write down this division, you have to pay attention to the unit. The one that go in the bottom part should have the same unit as the number that you want to convert. Then when you do the conversion, these two cancel out, and this one will be the required unit that you are going to use. Let's do another example. It says determine the number of minutes in half a day. So I have here half a day, and I'm going to do some conversion. Usually we know that we are going to do it with the number of hours. So here is also, I need to do one correction. This one is 24. So we usually know that one day, let me type it, it's much easier. When I type first, you will not see it, but when I click the enter, you could see. So I know that one day is 24 hours. So this is one of the things that I know. The other things that I know is that 1 hour is equal to 60 minutes. So usually you have to start from anything that you know because from the beginning you don't know in a day how many minutes you know. But easy way that it's come to your mind is that you know one day is 24 hours, then you know 1 hour is how many minutes. And then I have to build this division part. So because it's here in day, I have to write this division in a way that the day is in the bottom, in the top one is another unit. So I know one day is 24 hours. I will write this equality. And then I have to, when you look, this day by this day is cancel out, but at the end on top part, I have 24 hours. Still, it's not minute. I have to use another conversion for converting hour to minute. But how I should write this one, which one should be in top, which one should be in the bottom, is that this is hour, so I have to put hour in bottom to cancel out each other. So I will use it this way, 60 minutes over 1 hour. The result is 1, and you can multiply any number with 1. So if you do the calculation in here, the operation in here, this hour and this hour will cancel out. 24, half, and 60 will multiply together. And the unit that is left in here is minute. So it will be 720 minutes. Any question? Let's do another example, make it more clear. So usually one of the questions that you have in the homework and also in the quiz or in the exam is this conversion. You just need to how to know some equality, which is some of this table. You could bring this table to the also exam. I don't expect you to memorize it, but it's like good to know what is the relationship. But what is important for me is that when I say 2.2 yard to the meter, I would like to see at least one level of conversion. I don't want to see 22 yard equal to 2.021 meter, because if you give it like to the net, it will exactly will give you this one. But I would like to see this operation in here, that's what you've done. Either, for example, 1 yard is 3 feet, and then the feet is not what we want, so you have to convert feet to inch. 1 feet is equal to 12 inch, and then still it's an inch, it's not meter. But if you look at that table, you also know that 39.37 inch is equal to 1 meter. And that's why you arrange it. And at the end, you have this yard canceled by this one, this feet canceled by this one, and this inch canceled by this one. And if you do the multiplication in here, the result is 2.012 meter in here. Any question? Do you want me to do another example? Yes, no? Okay, let's do this example. It says in Europe, Canada, and many countries, the speed limit is posted in kilometers per hour. But in America, we have it miles per hour. So we want to have some sort of understanding or some sense that how fast in mile per hour is when we have the limit of 100 kilometers per hour. So here, the point is that when you have kilometer per hour and mile per hour, you don't need to do the conversion for hour. You just need to do the conversion for kilometer to mile. So I usually know that 1 kilometer is 1,000 meter. I also know that 1 meter is 39.37 inch. I also know 12 inch is 1 feet. I also know that 1 mile is 500 to 80 feet. As I said, you may know from the beginning what is the conversion between mile and meter, but you have to show it at least one level. So by one level, it means I have to see one of these parentheses. You don't need to do it exactly like this one, but at least you have to have one of these. Or maybe in the question, I just give you some information that 1 feet, what is the relationship between kilometer and meter, meter and inch and feet and mile. And then you have to do it this way. So here in the book, in this example, you don't have it in the question, but usually in the exam it will be given to you. That 1 meter is how much inch, how many inch is how many feet, and how many feet is how many mile, and you have to figure it out first, do the conversion from meter to inch, from inch to feet, and from feet to mile. And then if you see in here, kilometer cancel, meter cancel, inch also cancel, and feet also cancel, and the remaining is mile. So all these number is multiply and divide together, and this will be your final answer. So 100 kilometers per hour is usually 62 miles per hour. Any question? So if there is no question, this is end of chapter 1, which is introduction, and it was like a short chapter. So we are done for today. Any question?
Yeah. We meet on Wednesday, right?
Sorry, I
Hello?
was mute. This Wednesday, because we don't teach that much, we don't have, because Wednesday is for the lab session, and we don't learn that much. So we don't have lab this Wednesday. But we
Okay,
have,
so no homework, no class on Wednesday, right?
yeah, no, if you have homework, it's due Mondays, because Monday is for the lecture. So when we
Do we have
chapter
homework this week?
next Monday. So chapter for the next Monday. The syllabus, I send it through because you ask questions. Some of you ask question in chat section. Syllabus, I sent it to you through the email that you have it in the Blackboard. No, you don't need to come in online on Wednesday. I also will send you a time. It's usually be Mondays around 5 to 6. Also will be like a office hour. If it was like a class, we could see in person, but here I can be online. You just need to send me an email, and then I can be online and answer your question. So Monday from 5 to 6 is your is my office hour. So if you have any question, like any question from homework or any problem that you're solving or any point that you need more clarification or more explanation, you can reach out to me. I recommend you send me an email in advance, but usually even around 5:30 before class, just send me an email and say I have this question, then we can use the Blackboard login and like go over your question or problem and so on. And no, this Wednesday we don't have class. I will also send you email just to have it official. Yes, I will create a link for you on the Blackboard. We'll send you an email that this assignment is created. Now you can go ahead and submit. Deadline for the homework is Monday before coming to the class. So it's 6 p.m. next Monday. It's the deadline for the homework. Any other question? You're welcome. Thank you. So if there is no other question, any particular format for the homework? No, you can use any paper. Just you don't need to write down the question, just the answer, but don't put final answer. I don't accept final answer. I should see like your method or your approach, okay? I said the book is available on the net. Look for it. You will find it. Yes, you will submit your homework on Blackboard. The name of the book is also mentioned in the syllabus, first page. So if anybody has a question, you can like raise hand, talk, or type in the chat section. If you don't have any question, make sure you receive the attendance. If you like log in after I did the attendance, just let me know so I can give you the attendance. Important things. After 15 minutes after the class, like after 6:15, you will get tardiness if you log into the class. I will give you the attendance, but it's considered as a tardiness. 2 tardiness considered as the 1 absent. This is also another rule for the class. So make sure come in the class online, because I usually give like a couple of minutes for students to join. But I once, like by 6:05, start the lecture. Okay, any other question? If you don't have question, you can leave the class. Have a good night. Stay safe and warm. You're welcome. Yeah, everybody can type in this chat section. And I could see your chat. Everybody could see the chat. Also, I think you could ping me a direct, like a direct chat. You're welcome, Simon.